Welcome to Chapter 13, Statistics. Statistics is the science of collecting, analyzing, and interpreting data. Carl Pearson, a pioneer of statistics, lived from 1857 to 1936. You've already learned about measures of central tendency, mean, median, and mode, but these alone don't tell the whole story. We also need to understand how data is scattered or dispersed. Why study dispersion? Consider two batsmen with identical means of 53 runs. Batsman A scores range from 0 to 117, very inconsistent. Batsman B scores range from 46 to 60, very consistent. Same average, but completely different performance patterns. Central tendency alone can be misleading. We need to measure variability. The four main measures of dispersion are range, the simplest measure, quartile deviation, based on quartiles, mean deviation, using average of absolute deviations, and standard deviation, the most widely used measure. Each describes how scattered the data is around the central value. Range is the simplest measure of dispersion. It equals the maximum value minus the minimum value. For batsman A, range equals 117 minus 0 equals 117. For batsman B, range equals 60 minus 46 equals 14. The larger range indicates more scatter. It's quick and easy, but has limitations. Range has serious limitations. It only considers the two extreme values, ignoring all observations in between. It doesn't measure dispersion from any central tendency. A single outlier can dramatically change the range. We need more robust measures that use all the data. Mean deviation is the average of absolute deviations from a central value. It uses all observations, not just extremes. It measures scatter around the mean or median. The formula is MD of A equals sum of absolute values of xi minus A divided by n. This gives a single number representing average distance from center. Why use absolute values? Deviations from the mean can be positive or negative. In fact, the sum of all deviations from the mean equals 0. This is a mathematical property. If we didn't use absolute values, the mean deviation would always be 0. The absolute value represents the actual distance from the central value. Mean deviation about the mean is calculated as MD of x bar equals 1 over n times the sum of absolute values of xi minus x bar. First, calculate the mean x bar. Then find each deviation from the mean. Take absolute values of all deviations. Finally, average these absolute deviations. Mean deviation about the median uses the same process, but centers on the median m. MD of m equals 1 over n times sum of absolute values of xi minus m. First, find the median by arranging data in order. Calculate deviations from the median. Take absolute values and average them. Let's work through an example. Data 6, 7, 10, 12, 13, 4, 8, 12. Mean equals 72 divided by 8 equals 9. Deviations from mean, -3, -2, 1, 3, 4, -5, -1, 3. Absolute values, 3, 2, 1, 3, 4, 5, 1, 3. Mean deviation equals 22 divided by 8 equals 2.75. Variance is another measure of dispersion. It's the mean of squared deviations from the mean. The formula is sigma squared equals 1 over n times sum of xi minus x bar squared. Instead of absolute values, we square the deviations. This avoids the zero-sum problem and has nice mathematical properties. Standard deviation is the square root of variance. We write sigma equals square root of 1 over n times sum of xi minus x bar squared. Taking the square root brings the measure back to the original units. If data is in meters, variance is in meters squared, but standard deviation is in meters. This is the most widely used measure of dispersion. To calculate standard deviation, first find the mean of the data, then find each deviation from the mean. Square each deviation. Find the average of these squared deviations. That's the variance. Finally, take the square root to get standard deviation. A shortcut formula for variance avoids calculating individual deviations. Sigma squared equals 1 over n times sum of xi squared minus x bar squared. Alternatively, sigma squared equals 1 over n squared times sum of xi squared minus sum of xi squared. This is computationally more efficient, especially for large data sets. For group data with frequencies, standard deviation uses weighted calculations. Sigma squared equals 1 over n times sum of fi times xi minus x bar squared. Here xi is the class mark, phi is the frequency, and n is the total frequency. The principle is the same, but each value is weighted by its frequency. The coefficient of variation is a relative measure of dispersion. CV equals sigma over x bar times 100, giving a percentage. It's unit-free, allowing comparison between datasets with different units or scales. Higher coefficient of variation means more variability relative to the mean. Use coefficient of variation to compare different datasets. Suppose Team A has mean 100, standard deviation 10, giving CV of 10%. Team B has mean 50, standard deviation 8, giving CV of 16%. Team B is more variable relative to its mean, despite having a smaller absolute standard deviation. Standard deviation has important properties. It's independent of origin. Adding a constant to all values doesn't change the standard deviation. It scales with the data. Multiplying all values by a constant multiplies the standard deviation by that constant. Standard deviation of a plus bx equals absolute value of b times standard deviation of x. Watch out for common mistakes. Don't forget to take the square root when finding standard deviation from variance. Use the correct formula for grouped data with frequencies. Remember to use absolute values in mean deviation. Never compare standard deviations without considering the means. Use coefficient of variation instead. Key formulas to memorize. Range equals maximum minus minimum. Mean deviation equals 1 over n times sum of absolute values of xi minus a. Variance sigma squared equals 1 over n times sum of xi minus x bar squared. Standard deviation sigma equals square root of variance. Coefficient of variation equals sigma over x bar times 100. Problem-solving strategy. First, identify whether data is ungrouped or grouped. Choose the appropriate measure based on the question. Use shortcut formulas when they make calculations easier. When comparing variability between datasets, always use coefficient of variation for a fair comparison. Let's find the standard deviation of 2, 4, 6, 8, 10. Mean equals 30 divided by 5 equals 6. Deviations, -4, -2, 0, 2, 4. Squared deviations, 16, 4, 0, 4, 16. Variance equals 40 divided by 5 equals 8. Standard deviation equals square root of 8, approximately 2.83. Comparing our batsmen. Batsman A has mean 53, standard deviation 35.2, coefficient of variation 66.4%. Batsman B has mean 53, standard deviation 4.3, coefficient of variation 8.1%. Same means, but vastly different variability. Batsman A is much more inconsistent. The high coefficient of variation reveals this. Statistics has countless real-life applications. Quality control uses standard deviation to monitor manufacturing consistency. Finance uses it to measure investment risk. Sports analysts use it to evaluate player consistency. Scientists use it to analyze experimental data and determine significance. In this chapter, we learned that dispersion measures how spread out data is. Range is simplest, but only uses extreme values. Mean deviation uses absolute values of deviations from a central value. Standard deviation is the most widely used measure, based on squared deviations. Coefficient of variation enables comparison between datasets with different scales. Thank you for joining Chapter 13 on Statistics.